Hello, and welcome to another Unreal Engine 4 tutorial. I've been getting a lot of requests for things relating to Niagara, and those videos seem to be fairly popular, so I figured I would do a series that goes a little bit more in depth on things you can do with Niagara. To do this, I'm going to take a look at the content examples that Epic has provided for Niagara, because there are a lot of really cool features that those show off, and the particle systems themselves are pretty neat, if a little simple, just there to sort of show off different things that you can do with the engine or with the Niagara editor. So I'm just going to be doing some videos where I focus on one of those content examples per video and then sort of see what we can do with that. And the first one that I'm going to focus on is, as you can see here, this Unreal Engine 4 logo that is basically a texture that's being sampled by particles. And so you can see in this, they're doing this neat little effect where it samples the texture and the particles fall away at a different rate to kind of do this dissolve thing, which is pretty cool. And it looks like something that you would have in like a cyberpunk style game, a sign in the city of the future. So I kind of wanted to do something a little similar to that. And if you watch the Epic live stream recently about this content example, or about Niagara, where they talked about this content example, they mentioned, they had a couple questions, and they mentioned the possibility of doing this with flipbooks or sprite sheets, so where you could have an animated texture that you're sampling, as well as doing some things to optimize it a little bit more, like killing particles that are sampling, 0 alpha or black color, so that you won't have as many particles and it'll be a little bit more efficient. So I'm going to focus on doing a particle system that does that. And we're going to do a couple things like creating our own modules to do some of this stuff. And so without any further ado, let's jump over into the editor and get started on this. So as you can see here, I have a first-person project set up. I just have some folders that I've already set up here, and we're just going to start by enabling the Niagara plugin, as you need to do this to use it, as we've gone through before. So I got to restart. So we're back. And so now that we have the plugin enabled, we can go down and go to FX and add a new Niagara emitter. This time we are not going to use any of these templates that are already here, because this is a little bit different than a lot of the templates. So there's not really one that's very good for what we're about to do. Although I will show you in a moment that creates some headaches for us. So if you click on this, create an empty emitter with no modules or renderers, and hit OK, it'll do that for you. And we're going to name this particle emitter Niagara HoloSign. And so we have this, it's empty, and there are going to be some things that we run into really quick here that are, I'm assuming, glitches. In the making of this particular particle system, I've had a lot of issues with Niagara, some crashes and things like that. So, keep in mind that there may be some troubles while you're going through this. But if you stick with it and troubleshoot it, you should be able to get a pretty cool particle system out of this. So the first thing we're going to do here is we've got the emitter, and we've got emitter properties, and we're going to make this a GPU sim, because we're sampling from a texture, and we're also going to have a ton of particles because we're trying to sample at a pretty decent rate. The particles are essentially going to be like pixels, so you want it to be GPU. And we're going to do fixed bounds for this, because we're going to know exactly where these particles are going to be. So we're going to go -300 to 300 on all 3 axes. We're going to close the properties, and we're going to open up an emitter update to get the life cycle module. And we're going to go in here and turn off autocomplete. And we're going to set the loop duration to 1. And then we are going to add a spawn particles in grid. And essentially what this is doing is it's just going to spawn all these particles in a grid at a certain number of intervals that we specify. I'm going to save this real quick, because we're about to see one of the issues that I had. So you see this says the module has unmet dependencies, and basically what it needs is, in particle spawn, it needs a grid location module to tell the particles where they should be. So if you just click fix issue, you get a grid location. And Unreal crashes. So we're going to restart that real quick. And I kind of banged my head against this one for 5 or 10 minutes and just did a bunch of different permutations until I could find out what the issue was. And for some reason, if you have the emitter set to GPU sim, and you have no renderer assigned to it, so nothing under the render part of the stack, and then you try and put a grid location in, it crashes immediately. So I can show you real quick. If I change this to CPU for whatever reason and hit fix issue, it works fine. So now I'm gonna just real quick, I'm not gonna change it back to GPU just yet because I don't want it to crash again. I'm going to go down and add a new renderer, and we're going to add a sprite renderer so that there's something here so that it doesn't yell at us. And then we're going to change this back to GPU, and fingers crossed it doesn't crash. It didn't crash. So weird issue. There will be things like that in, you know, an unfinished feature like Niagara. So just, you know, cut it a little slack. It's a little frustrating, but it's, you know, something that I figured out a workaround for. So you should be able to get this to work without that hampering you too much. So we're gonna change spawn particles in grid. We want the count to be X and Y 256 and Z to be 0. Essentially, we're telling it to spawn particles, enough particles that are essentially going to be the resolution of the image that we are sampling from, which we don't have to do, and we'll change that a little bit later for efficiency's sake, but I just wanted to spawn this many so you can kind of see what it looks like. So the other thing, now that we've changed the spawn particles in grid in emitter update, we can go down to the grid location, and we want to change this dimensions definition to bounding box size, and we're going to change this to 256 by 256 and 1. So now we've got a bunch of particles spawning here in a grid, and so this is going to be the fundamental building block for this effect, because we're going to take all of these and basically say wherever you're spawning, sample from this texture at that UV location. So we've got this sprite render component down here, our module down here, and we are going to add the default sprite material for the time being. And it's not showing up. So we need plugin content, I believe. Okay, yeah, so if it's not showing up, plugin content is what you want. And there are two different ones. You want the one that's basically just a soft white circle. And you can see, since this is an unlit additive material, essentially we're adding like 60-some thousand particles on top of each other, and it's getting super bright. The other thing you'll notice is that we're getting a crazy number of particles because since we used an empty template, it doesn't even have the age update for the particles. So even though I even haven't set the particle lifetime yet, but even if I did, they wouldn't know when to die because they're not being told that. So now you can see I have particle update age, but now it's yelling because it doesn't know the lifetime for the particles. So we're gonna set that real quick so that they have a lifetime. So set particles lifetime, and we're gonna go probably 1 second. It should be just fine. So now you can see our particles are coming in, spawning, and then dying after a second. So we're not getting crazy number of particles, just the number of particles that we should be getting from a 256 by 256 grid. So we've got all that set up now. So we've got the lifetime. The other thing, though, you can see is that these are pretty huge, and they're just kind of overlapping and just activating bloom like crazy. So we're gonna change the sprite size to 1 by 1. So now we have a grid of what is essentially going to be pixels here. So it looks much better now. It's not like activating bloom like crazy, and we're just getting 256 by 256 pixels. And what we can now do with this is and this is not the way that we're going to do this for the final effect. I just want to kind of show off the sample texture node so you kind of know the general gist of how this is working. So we're going to go and we're just going to select a random texture. They don't know how to sample just yet. So basically what this module is going to do is it's going to take in a UV and then go into that area on the texture and pull the color value from that and then output that. So we need to do a couple things here. We need a UV value, first of all. So we're going to split vector 2D on this. So we get two different values here. And then we're going to make float from a vector. And we want the X vector for the X. And we're going to link this to another value, which is a variable that's being created by the grid location, which is output grid location normalized array location. So essentially, you can do the actual location, but that's going to be a big number. We want the normalized location because in a 256 by 256 grid, that is going to correspond to the actual location on the image that we want to sample from. So we're going to click that. And actually, I can just show you real quick so you know, like if you go up here to this little eye, you can go to show outputs, and then you can look at each module and see what it's outputting, so you can actually see that grid location normalized array location is there. So we've got that, and then we're going to do the same thing for the Y. So we're going to make float from vector. We're going to go to the Y axis for that one, and we are going to type in grid to get grid location right there. So now we've got that, but you see it's still not doing anything. So essentially what this module is doing is it's getting this color at the location and it's returning the UV at that location. What we need to do is we need to now tell the particle that it should accept this color as its own color. So we're going to get a color module here. We're going to put this here, and we're just going to say sampled. And so now we have the output sample texture, sample color that we can link it to. So now you can see we have exactly what we wanted. We're sampling colors from this texture, and that is what we're giving to the particle. It's also sampling alpha, everything that you would need for linear color. So if I open this asset real quick, we can look at that. Essentially, all this module is doing is it's taking in a texture and a UV, and then it's calling this function, which you can't open for some reason. Most of these functions you can open and see what they do. But it's essentially just sampling at a UV location what the color is and returning that as a linear color. So great, perfect, that works fine. You'll notice that we're basically, even the things that are invisible here are still counting as particles. We're going to fix that way later. I just wanted to show you how this works. So now that we have this set up, you can kind of get the idea of how you start sampling things here. But what we want to do is we want to sample from a sprite sheet so that we can have an animation playing on this particle system. And there is a SubUV sample, a texture sample node in here, or module in here. I don't actually know how it works, and I couldn't quite figure out how to make it work for this purpose. So essentially, you're inputting a phase, a texture sample, and an X and Y count. And you can open up these and actually look at what they do. I'm not going to go too far into this. But essentially, it's returning offset to pixel center, which I'm not really sure what that is. And you can't really, there's not a lot that you put into this module to tell it what you want. So like essentially, what I want from this module is to be able to put in how many X and Y images there are, what index I need, and then a UV for the pixel. So this is not going to work for our purposes. I might just be dumb and not know how to use this, but this is not quite what I want. So we're going to create our own module to do this, which I will do in just a second here. So first, before I do that though, I'm going to input the texture that I'm going to be using. So you can see it's just a really simple sprite sheet that I made in a couple minutes in Photoshop. I just wanted something that would look like a sign that you would have in a sci-fi city. So we're going to do a couple things here. We're going to compress it without alpha. We're going to change this to compression vector displacement map. For some reason, that was the best one that I could find to get fewer artifacts, so I just kind of played around with it. Basically, all we want is that, low compression, because otherwise you're going to have pixel sampling like compression artifacts and things like that, which you don't really want. We're going to go no mip maps here. I don't think that the sampling is actually looking at mip maps at all, regardless of how far you are from the particle system. So I just decided to throw those out. It's less resource to have no mip maps here. And then I'm just going to change a couple color things here that you wouldn't necessarily do to your own image. I just kind of was tinkering with the color to get a color that I liked for the particle system. So I'm just blowing the colors out here. So we've got that now. So we've got our texture, and now we're going to go and we are going to create our SubUV sampling module that we're going to be using. So easiest way to do this is to we got to get rid of this one, is to go to the sample texture and right click and go to show in content browser, and then we're going to right click and duplicate it. And then we need to move this to where we want it to be, which is our folder for this effect. And you want to make sure you duplicate this so you're not just changing a module like a stock Niagara module. So I'm going to move this into the folder that I have made for it. And we're going to rename this SubUV texture sampler by UV, because we're using UVs of pixels to determine what we're sampling. So we're going to open this now, and now we're going to start messing around with the module editor here. So this is actually a really neat little setup in Niagara. It's not quite as easy as using Blueprint. Some of it does not feel as well set up to me because it's a little confusing starting out, but once you get used to it, it's pretty neat, and there's a lot of functionality hidden away in here. So what we're going to do here is we're going to add a bunch of inputs. And basically how this works is you have an input map that you get, and you're able to pull off values from what's being input. And then at the end you have an output map that's being set that then gets output from the module back into the system. So the way that you add variables for the input is to go over here to module and add, and then you can select what type you want. So we're going to do a couple different types of things. We want to do an index, which is going to be a float. So this is just going to be the SubUV index. Basically, we're just telling it which image that we want to read from. So I'm going to call it SubUV index, and you'll notice that this is not being referenced yet. It's got this little 0 here, and it's not in the map. So you have to come over here, go to module, and then SubUV index. That's what we want. And now you can see now that I've referenced it in here, it's got a 1 next to it. So we're going to add a couple more things. We want to add a couple. Add a couple of ints. One is going to be x count. So this is the number of images along the x-axis, or number of rows. And then we're going to add y count, which is going to be the number of columns. And you want to make sure that you leave the prefix on these, because the module is basically essentially telling it that this is a variable that is being used in input. So we've got those. Now we just need to add those. So we've got module X, and we've got module Y. And I think that's all we really need to add here. So essentially what I'm going to be doing here is using these inputs to figure out where the image is, in the sprite sheet, and what part of it we're going to sample. We've already got our UVs here, which is what we had before, what we wanted. I'm going to start off. I'm going to actually move this down. Okay, that's at the bottom. So the first thing we want to do is to get a float value here, and we'll just have that as 1. And you'll notice, so I'm making a float here. This has this interesting little wire in the middle of it, and this is called like inline swizzling or something like that. So essentially what you can do is you can add a bunch of different things, and then like in the module you can actually do a bunch of changing, redirecting wires and things like that. It's a really cool feature. I haven't really found a use for it just yet, but I'm sure, you know, in blueprints and other things in the material editor, there have been times where I wished for something like this so I can clean stuff up. But we're not gonna use that here. This is gonna be pretty simple. So you can just close that off by hitting this little wrench up here. So cleans it up a little bit, looks a little bit nicer. We're gonna hold D for divide, and we're going to divide this one value of 1 by the X and the Y. So essentially we're using this to figure out how many images per row there are going to be. So we're going to use this then to make a vector. So make a vector 2D. We're going to close off those wires again. So now we've got a vector that is basically our X and Y scale. So now if we hold M, we get multiply, and we're going to multiply our UVs by that X and Y scale. Now we can plug that into the sample texture, and also plug it into the, well, I might not do that yet, but we'll plug it in the sample texture so we can take a look at what it's doing. And then we'll go back to the particle system, and we're going to get rid of the sample texture, and we're going to add our SubUV sampler by UV. So we've got this now. We're going to put this up here. We'll just leave the SubUV index for now. We want to have our wave sheet, and actually something I want to change real quick is I want, you can set the defaults for these inputs here in the get section of this. So if you save that, I'll go back. Okay, now if I hit these little arrows, it'll return it to the default, which should be 1. So then we need to give it the UVs that we want. So again, we're going to split vector 2D, and we're going to make, it'll let me make float from vector. That'll be the X, and we'll make float from vector again. And that'll be the Y. And then we want the sampled type sub. Oh wait, no, I don't want that yet. What I want is the grid. Sorry, I'm jumping one step ahead. I want the grid location from the grid location up here. So we're gonna get both of those. Now we've got that. Now we want to go in and get the sample. So now we've got SubUV texture sampler by UV sampled color. So now you can see, just like before, we had this thing where we essentially are just sampling this image. And so that's all our new module is doing so far, except that now if you tell it that there are 2 rows, it will actually scale the image to the row size, essentially. But this doesn't super help us because we've done nothing with the SubUV index yet. So you can see I changed it. We still have the same image. So we want to go back. And now we want to build in a way to offset the image so that we're showing whichever index we want to show. So the way that we're going to do this is we're going to take the X count and we're going to fmod that. And fmod is essentially like getting the remainder, if you're unfamiliar with it. And actually, we want to take the SubUV index and fmod that by the X, so by the rows essentially. And then we also want to get a divide, and we want to divide the SubUV index also by the X. So what this is doing is it's saying that like for however many things along the X you have, if you haven't basically spilled over to the next value yet, you're still in this row, is what this is going to split out. And then vice versa, this one is basically saying that like you have spilled over to the next row because you filled, 3 out of 3 or whatever number you put in. So essentially what we're going to do is we're going to take these and both of them, we're going to floor them, which is rounding them down, because we only want whole numbers and we only want it to flip over once it's gotten to the next value, the next whole number value. So then we're going to take this vector 2D and we're going to duplicate that. We're going to add both of those in there. So now we have our X and Y offset in this vector 2D. And what we want to do, or we have the magnitude of that X and Y offset. And what we want to do is multiply it by this number that we've gotten already. And that's going to give us the actual UV offset that we want. And then we're going to add, so we're going to add these two values together. So we're adding the scaled UVs, or adding the offset to the scaled UVs, so that not only are we scaling it, but we've also moved it to the position that we want it to be in. So now, if I've done everything correctly, we should be good to go. And I'll just plug this in here. We're not actually going to use this sampler UV thing. That's just a holdover from the sample texture. But if you wanted to pull those UVs and use them somewhere else, that's basically what you'd use that for. And I think that's pretty much everything we want to do with this. So if we go back and we take a look, so now you can see it actually changed. So if I go to 0 here, we've got welcome. If I go to 1 here, we've got welcome to. If I go to 2, welcome to Angel, and then 3 is welcome to Angel City. And the image is moving slightly. The hand is waving at the same time. So now we have built a little system where we can take a sprite sheet and sample that given a pixel UV. So great. We're well on our way here. We want to change the SubUV index based on the emitter age. So we're going to link that to the emitter age. And essentially what that's going to do is for every second, it's going to, like every second that exists, then it's going to create the next image. So it's going to be 1 image per second for this particular particle system. We've got the lifetime of the particle set to 1 second. So once 1 second is up, particles die and it spawns new particles. So now we've got an animated little thing that just goes off on its own. Since this particle system does not have a maximum loop count, it's just going to go on indefinitely. So that's perfect for us. It just keeps animating the whole time. We want to change some color stuff because this isn't 100% the way we want this to look. You know, it just kind of pops. We want to give this sort of a little bit more interesting behavior. So what we're going to do is we're going to go to update. We're going to go to color, and we want the particle color params. Now we're not actually going to take any of this color values. We just want the alpha channel, and we're going to multiply float here. And so we're basically just going to take the original alpha, which we're going to get float from curve, or from, sorry, make float from linear color. And we want the W value, which is going to be the alpha. And we're going to set that to particle's initial color. And then for the B value, we want a float from curve. So we've got float from curve now. And we're basically just going to have these fading in. So at 0, 0. And then we're going to add, why is it not adding? There we go. We're going to add at time 2.5 a value of 1. And then we're going to add another value probably much later, like 0.85-ish, if I can type. And that'll be a value of 1. So essentially they fade in a little bit and then they fade out a little bit. Fade out a little bit quicker because we're going to have them update into the next frame like that. But so now we've got that. So we've got fade working in our favor. We're also going to change this color just a little bit so it's a little bit brighter. You notice this is not super bright for something that's supposed to be like a holographic pulsing screen. So we are going to change this color value that we're giving it initially by multiplying linear color. So we're gonna relink our sample, and then we're gonna multiply it times 5 for all the colors. So now you'll notice it's much brighter. If I just turn the preview scene off, so it's not seeing itself as not so bright. You can see it's a super bright little screen. It even activates bloom if you get on the side of it. It looks pretty cool. So we've got the color sorted now. Now we're going to add forces and velocity in here, and this is used in most particle systems. Solve forces and velocity. This is basically what allows you to update the velocity of the particle. And since we used an empty template, it wasn't in here already. But we're not going to do anything with that. We're just going to close it. It just needs to be there. But we're basically, we're looking at this. It's pretty static. It doesn't look super interesting right now. So we're going to add a neat little cheap effect that we can do that'll give it a little bit more life. So what we're going to do is we're going to go into set variables here, and we're going to create a new variable. It's going to be a vector, and we're going to call this location offset. So we got that now. We're going to split this. And for each of these, we're going to make them uniform range. The reason why I'm doing it this way is because if you just made it uniform ranged with the vector itself, then they would always range the same way, which I don't quite want. I want each of these values to sort of be independent of each other. So we're going to go -25 on the x to -25 to 25, and -25 to 25 on the y, and then -50 to 50 on the z. So it'll have a little bit more depth once we get this all plugged in here. So now we've got that, and now we want to add another new variable in here, which is also going to be a vector, and this is going to be called particles end position. If I can type. And we are going to link that to the... Oh, it's not setting the position yet for some reason. Interesting. Why did that move? Okay, so let's set this. I had a little bit of a problem there for some reason. Let's try that again. And then I suspect if this doesn't work, we're going to have to set this in a separate little, if it'll let me, end position. So if this doesn't work, we're going to have to set this in a separate little window. Sometimes that happens. See, oh, there it is. For some reason, it didn't show up before, but now we've got particles position. So that's what we want. So basically what we're saying is whoa, something went super wrong there. Oh my God. So that shouldn't be happening. Oh, the size of the sprites got reset. Yeah, so essentially what I'm doing here is I'm saying that the position that the particle has sampled from is going to be the end position of the particle, and then I'm going to move them a little bit so that they have to move towards that end position. So now that we have that set, we are going to add another little module here, and the reason why we're adding another module to set this is because if we set it in the same one, you might potentially be overwriting this before it's setting this end position. So you just want to set this as a separate one. Where'd it go? Here it is. Okay. So we've got set variables, particles position, and we've got engine owner position. We're actually going to change that. We want to do an expression. So we're going to make an expression for this. And essentially what this is going to be is it's going to be particles dot position plus particles. Wow, I'm having all kinds of trouble today typing. Particles location offset. So now you can see our particles have all been sort of just scattershot spread. And you can kind of see that you still get the animation in there. If you look way far away, you can see it a little bit better, but it's a little bit harder to see now, but we're gonna change this in a second so that it looks a little bit more sensible and you understand exactly what I'm going for here. So we've got the offset here, and we've got our end location that we desire to have set up there. What we want to do here is we want to set the velocity. So we get the velocity. We're going to add the velocity in here. I'm going to move this above solve forces and velocity, otherwise it'll yell at us. And we're also going to do an expression for this one. So we're going to make new expression, and we're going to say particles end position minus particles position, and we actually want to put this in parentheses. And then we want to divide that by particles lifetime. So we're essentially getting a velocity here, the velocity that it would take over the lifetime to move towards the end point that we want to get to, and then we're going to multiply that by 8 to speed it up just a little bit. But this is going to update every frame, so all these things are going to move in real fast. Whoa, I broke something there. Let's see, what did I do wrong? Particles end position minus particles position. Wow, that's like a rave. Oh, I added velocity. I wanted to set velocity. So little oops there. You want to set the velocity, not add it. Because if you add the velocity, then it's just going to get faster and faster every time. So what we're doing is we're setting the velocity so that instead of speeding up, it's actually going to slow down as it gets closer to the end point. So we're going to delete that. Now I've got this, and it should work. Fingers crossed. Yeah, so you can see now the particles all start at a random offset from where they should be, and then they just kind of zoom into their position and slow down over time as they get closer. So you can see now we've got this neat little pulse effect that happens every frame. It's almost like the pixels of this like floaty holographic display are reorganizing themselves to update the image. So now we've got this neat little, pretty cheap, pretty simple to do effect. You'll notice we still got 65,000 particles here, which is a lot. They're GPU particles, so it's not so bad. They're pretty simple, but we can do something here, or we can do a few things here to make this a lot more efficient than having all these particles. And the first thing I already mentioned, if I drag this, if I create a particle system and drag this out in the world, so I gotta open this so it'll compile. Well, what happened there? Did I not save that? I didn't save it. Okay, there we go. So now we want to rotate this. So it's upright. If I can rotate it. It doesn't want to rotate all the way for some reason, but we'll get there. Okay. Hit play, and we can take a look at this. So you can see there is a lot of empty space in there, and there are particles in there. Essentially, anywhere within that square, there are still particles. But there's empty space because some of them are just essentially blank alpha particles that have, nothing to them. But so what we want to do is basically tell this thing that whenever a particle is assigned no alpha, or when it's supposed to be transparent, that it should just kill and then not be updated every frame. So the first thing I tried for this, and this is the idea that I got from that live stream I mentioned, which I'll link in the description below, is to just do it using the alpha, so that whenever a particle has an alpha of 0, that it will just kill. However, for whatever reason, I built this module that checks, and then I added the numbers in, and prior to adding the alpha numbers in, it worked fine with that for whatever numbers I put in. But trying to use the alpha for some reason, Niagara was giving me a lot of trouble. I'm not really sure, because I was using an image that had alpha, so it was sampling 0 and 1 values. It just wasn't feeding them in correctly for some reason. However, with this image, I haven't given it an alpha. So if you look at this, it's literally just 1 for the alpha, and we're compressing it without alpha. So it's just got black value. So instead what I'm going to do is whenever the color value of something is 0, then I'm going to kill the particle. So we're going to go back here to Niagara modules, and we're going to right click and create a Niagara module script, and we're going to call this compare particle scalar kill. So essentially what we're going to do is we're going to build a module that can compare any scalar value we give to it, and then if the scalar value is not greater than what we're comparing it to, then we'll kill the particle. So we're going to open this. It's empty as of now, so what we want to do is add to this a float, and we want this to be scalar. And you can see, since I didn't put module in front of that, it immediately freaked out and put it in other. So you want to make sure that the namespace is correct. So we got module scalar. We're going to have another float here, and we want this. We're going to want to name the scalar to compare or something like that. So this will essentially just be a scalar that we plug into. We'll just make it 0 here, but to make this a little bit more useful in the future, you can change this and make it whatever number you want it to be. So now we've got those two numbers here. We're going to add those right here. So we got scalar, and then we got scalar to compare. We're going to drag this out a little bit. And we're also going to add one more thing here, and we're going to add data instance alive. And essentially what this Boolean is it's whether or not the particle should be cleaned up at the end of this execution cycle, so at the end of the frame. So we're taking that value, we're going to feed this in, and we're going to compare these two. So we want to get greater than, so we want to see if the scalar is greater than the scalar we want to compare it to, but we don't want to just plug this directly into the data instance alive over here, because if we do that, we're going to have this on update, doing it every update, because these things change over their life. If we do that on update, then it will essentially look in the particle update age module and say, okay, this thing is old enough to die, and it'll tell it, okay, you should die now. And then if we have this directly after that, then just checking this thing and saying, but wait, this one is opaque, it should live, it overwrites what the update age thing is saying. So what we want to do instead is we want to get an if statement here and plug in data instance alive, and then we want to get a bool to come out of this that will plug back in the data instance alive. So basically this is saying, if this instance should be alive, then you can check to see if this scalar is bigger than this scalar. And if it shouldn't be alive, if it should be killed on this frame, then just kick out a false and it should die. So this right here should handle what we want it to. So now we've got all that. And if we just go into our hologram, then we add our compare node. And we'll just put this right after the update age. So we'll leave the scalar to compare to 0, but we will put in float from linear color. And we're going to grab the Z value, which is the blue value, because most of our image is bluish. So we don't want to lose any data where maybe there's not red or green, but there is blue. So we're going to use the blue, which is Z. And we are going to grab particle color. So if you were updating particle color over the life of the particle, this would check every frame to make sure. And now you'll notice that we have half as many, like at peak, we have half as many particles as we did before. And on some frames, we don't even have nearly as many. And this is kind of glitching out here, but if I just save it and we go look at it here, it works perfectly fine. So you can see, if we click on it, there are only particles where there should be. Whereas if I go in and I uncheck this and apply it, and go back out in the world and look at it, you can see there are particles all over the entire thing. So we've got that working now. Looks great. And that's pretty much the effect that we're going for here. We just got this really simple little sci-fi billboard that just updates. And you can do some much more interesting detailed stuff with this. I just wanted to kind of get the basics out there. But it looks pretty cool. It's not hard to do. You know, they're all GPU particles, so it's not crazy expensive, but we do have a lot. So there's some ways to optimize that I'll show you in a second. And also, if we just take a look at the optimization view modes, if we look at shader complexity, you can see, looking dead on, it's not so bad. But then when you look sideways, it is pretty bad because the overdraw gets super high. So if we just look at overdraw real quick, you'll notice not bad, awful. So that's just something to keep in mind, is that when you're looking at it from the side, there is a hell of a lot of overdraw, which can be an issue. That'll definitely, like, that's a pretty big performance hit, going from not demanding to pretty demanding with all that overdraw. Some of the things that we can do here to minimize the number of particles so we get less overdraw and stuff like that is you can actually change the number of particles that are spawned in the grid. So now we have fewer particles being spawned in the grid. You'll notice this is a lot dimmer because we don't have those particles so close to each other. So, maybe this is a look that you're going for. However, I think we could make that look a little bit better. So there are two different ways that you can tackle that. You can change the size of the particles, so now the pixels are just bigger, which could be what you're going for anyway. So you see, it doesn't look too bad, and there are far fewer pixels. So if we go back and look at particles, since we're having the resolution, we're getting a quarter of the number of particles. So that's a pretty big savings there. The other way that you could do it, other than changing the size of the particles, is to change the size of the system itself. So it's looking pretty dim here, but if we go up to this grid bounding box, then we can change that as well. So now it's as dense as it was before. The particles are the same size, but the image itself is smaller. So I don't know if I gotta save that real quick. So now you can see the image is much smaller. So maybe you want the image to be smaller, and that's a super easy way to deal with that. Or you could just make the pixels larger, so it's all up to you. Keep in mind, if you're changing the size of the bounding box, I did not change any of this offset stuff, so the offset is much larger, and it looks much more diffuse every time it resets like that. So just keep that in mind. For this, I'd probably just keep it at, or for this absolute specific particle system that I've just made, I prefer to keep it at this size and just make the I screwed something up there, and just make the sprites themselves a little bit larger. So now, so I think that's pretty good, and that handles exactly what I wanted it to handle. So you could do a lot with this. You could do a lot more interesting things than what I've done here. I just wanted to get a super simple, cool particle system out there that samples from a sprite sheet and is animated. I'd love to see what you guys could think up with this, because there is a lot of potential in this kind of idea. You could really push the boat out there with some really cool, cyberpunk style, Blade Runner-esque cityscapes with some cool billboards and stuff with these kind of things on them, with images that had more frames and things like that. So love to see what you guys can make with this. Thank you for watching. If you have any questions, just put them in the comments below. Any suggestions, put them in the comments below. Just as always, thanks for watching the video, and I hope you have a great day.